Good morning, children. Today 8.3. Listen, to learn exercise 8.3, we need the following concept. Say first of all, say for example, can you tell me what is 10 plus 2? Yes, 10 plus 2 equal to 12. Okay. Say addition of two real numbers is possible. Addition. Okay. Next, suppose, can you tell me 10 minus 2? Very good. 8. Next, suppose 10 into 2. 10 into 2 equal to? Yes, 20. Suppose 10 by 2 equal to? Yes, 5. Okay, which is real numbers. Listen, in real numbers, addition, subtraction, multiplication, division, all the four mathematical operations are possible. Okay, now come to our chapter, vector algebra. In vector algebra, say for example, suppose A vector is equal to, I cap plus j cap minus 2k cap. Suppose B vector is equal to 2i cap minus j cap plus k cap. Now I want to add, suppose addition. Okay, whether addition of two vectors possible or not? Good, possible. Okay, how to add? Very good. That is I cap, say I cap separate addition, j cap separate addition, and k cap separate addition. Okay, now addition of LHS, good. A vector plus B vector, which is equal to here I cap. So totally, good, 3 I cap. Next j, very good. Minus plus cancel. So plus is 0j. Plus is 0j, no need to write. Okay. Next come to k. Very good. Minus 2k plus k. While adding, minus k. Yes, minus k. Here middle 0 I cap, 0 j cap is opposite. Okay. So addition of two vectors possible. Okay, first one. Now suppose second one. Now subtraction. Subtraction of one vector. Say for example, consider the same. A vector is equal to the same. A vector is equal to I cap plus j cap minus 2k cap. Okay. B vector, yes. B vector is equal to 2i cap minus j cap plus k cap. Okay. Now I want to subtract. Yes, sign change in second row. Subtract. Plus change to minus. Plus change to minus. Minus change to plus. Plus change to minus. Okay. Start your answer. Yes. A vector minus B vector. A vector minus B vector. Which is equal to? Yes. Here I cap. Minus 2 I cap plus I cap. So your answer is minus I cap. Okay. Here plus I cap plus j cap. Plus j cap. So totally? Good. Plus 2j cap. Okay. Come to k. Here minus 2k cap. Here minus 1k cap. So totally? Very good. Minus 3k cap. Okay. Listen. Addition of two vectors possible. And the subtraction of a vector possible. Now say addition, subtraction possible. Now come to multiplication. Okay. Here multiplication of two vectors is possible in vector algebra. In vector algebra, multiplication is possible, but that is a product of two vectors. Product of two vectors is possible. That is product of the vectors two types. Product of the vectors two types. But in real numbers, there is only one product. 10 2s are 20. But in vector algebra, product of two vectors given by two types. The first one is scalar product or dot product. Here, scalar product means the answer which gives a scalar answer. That is product of two vectors which gives a scalar answer is a scalar product. Okay, scalar product gives a scalar answer. Okay, next the second type is vector product or cross product. Here vector product gives vector answer. Again, product of the vectors two types. Product of the vectors two types. First one is scalar product or dot product which gives a scalar answer. Second type, vector product or cross product which gives vector answer. Again, scalar product gives a scalar answer and vector product gives vector answer. That's all. And scalar product otherwise known as dot product and vector product otherwise known as cross product. That's all. So which is the basic. Now and also one more idiom. Here already I told you that is a 10 by 2 is equal to 5. In real numbers division is possible. But in vector algebra division is not possible. That's all. In vector algebra division not possible. Addition of two vectors possible. Subtraction possible. And multiplication possible, but multiplication contains two types. That is product contains two types. And division of two vectors not possible. See for example A vector divided by B vector is not possible. Okay. So in vector algebra, addition, subtraction and multiplication possible, where multiplication two types and division of two vectors is not possible. So that is a today concept. Product of two vectors. Today's topic is product of the vectors and here we are going to consider product of two vectors. Okay. Now product of two vectors, two types. That is, first one is scalar product, that is dot product. So first is subdivision scalar product. Scalar product. Scalar product, otherwise dot product. Okay. Product of the vectors two types, that is scalar product, otherwise dot product. Okay. Second subdivision is vector product. Vector product. Vector product, otherwise cross product. Okay. Scalar product or dot product. Vector product or cross product. Cross product. Listen, here topic itself the technique. Here dot product means just a dot. And the cross product means just a cross. That's all. So for dot product we want to use just a point, a thickest point, and for cross product, so this symbol we are going to use. So that's the idea. Okay. Now, listen. First one. First one is definition of scalar product, that is a dot product. Okay. First scalar product. Scalar product or dot product. Okay, scalar product, that is dot product. Now listen, let A vector comma B vector be any two non-zero vectors. Be any two non-zero vectors. Non-zero vectors. Okay. Let A vector comma B vector be any two non-zero vectors. Let theta be the angle between A vector and B vector. Let theta be the angle. Let theta be the angle between A vector and B vector. Listen again. See, we are going to see definition of scalar product, that is a definition of dot product. Let A vector and B vector be any two non-zero vectors. Let theta be the angle between A vector and B vector. Now listen, let us draw the diagram for this. Yes. Listen, which is A vector, consider, and it is B vector. Let O be the origin. Okay. Here A vector and B vector be any two non-zero vectors. Let theta be the angle between A vector and B vector. Let theta be the angle between A vector and B vector. Now, The scalar product is defined by A vector dot B vector. The scalar product is given by A vector dot B vector is defined as A vector dot B vector is equal to, is in A vector dot B vector is equal to. The scalar product of A vector and B vector is given by A vector dot B vector is defined as modulus A vector. Here first one A vector, therefore first one modulus A vector. Here second B vector, therefore the second one is modulus B vector. So second one is modulus B vector into cos theta, where theta is the angle between A vector and B vector. That's all. So first one is completed. Again, the definition of scalar product is given by A vector dot B vector, which is equal to, here first one A vector, so first modulus A vector, second B vector, therefore second modulus B vector, into cos is angle of theta, where theta is the angle between A vector and B vector. So first one is definition, which is complete. Children listen, the product of the vectors two types. First one is scalar product or dot product. Second type, vector product or cross product. Product of real numbers, no type, that is just a product. But product of the vectors, two types, scalar product or dot product, vector product or cross product. Here, scalar product gives scalar answer, vector product gives vector answer. That is concept important. Okay, now first, the definition of A vector, the definition of dot product is given by A vector dot B vector is equal to modulus A vector into modulus B vector into cos theta. Definition of dot product. Every time we want to use definition of dot product. That is very important. So definition of dot product is given by A vector dot B vector is equal to modulus A vector into modulus B vector into cos theta. That is very important. Now come to the next topic. Geometrical meaning of scalar product. Geometrical meaning of scalar product, that is projection of one vector on another vector. Geometrical meaning of scalar product is nothing but projection of one vector on another vector. Okay, for this, first let us draw the diagram. Listen, the diagram is very simple. To learn this sum, we need this diagram. Okay, listen, let O be the origin, and which is A, that is OA vector. Let OA vector is equal to A vector. Okay, let OA vector is equal to A vector. Next, which is OB vector. Let OB vector is equal to B vector. Okay, see, that is projection of one vector on another vector is the topic. Let OA vector is equal to A vector. Let OB vector is equal to B vector. Let theta be the angle between A vector and B vector. Okay, now draw BL perpendicular to OA. Draw BL perpendicular to OA. Okay, draw BL perpendicular to OA. That's all. Which is the concept. Now let us write the theory portion. Listen, theory portion is very simple. Let OA vector equal to A vector, OB vector is equal to B vector. Let OA vector is equal to A vector, comma, OB vector is equal to B vector. Okay, second step, good. Let theta be the angle between A vector and B vector. Let theta be the angle between A vector and B vector. Okay. Okay. Let OA vector equal to A vector. Let OB vector equal to B vector. Let theta be the angle between A vector and B vector. Now draw BL perpendicular to OA. Draw BL perpendicular to OA. Draw BL perpendicular to OA. Okay. Draw BL perpendicular to OA. Okay. This sentence is completed. Now, next here, listen, the topic is projection of one vector on another vector. Here, consider B vector. This B vector projection lies on A vector. That is, we are going to learn the projection of B vector on A vector. Okay? The projection of B vector on A vector. So which is the concept. Here, what is OL? Yes, where OL is equal to, where OL is the projection of B vector on A vector. So OL is equal to, now OL is equal to, OL is the projection of B vector on A vector. OL is equal to projection of B vector on A vector. Okay, up to this correct. Okay, now in triangle OLB, in triangle OLB, because OLB is a right angle triangle. Here where L is angle 90 degree, L is angle of 90 degree, so which is a right angle triangle. Here 90 degree opposite, good, hypotenuse side. Next, theta opposite, yes, opposite side. Theta opposite side. Again 90 degree opposite, hypotenuse side. Theta opposite side. One side is remaining. What is remaining side? Good, adjacent side. Where OL equal to adjacent side. OL equal to adjacent side. Listen, we are going to learn projection of one vector on another vector, which means here one vector considered as B vector. Projection of B vector on another vector, that is A vector. So where OL is the projection of B vector on A vector. So that is why where OL is wanted, and hypotenuse side is known, which is where magnitude is equal to modulus B vector. Magnitude of B vector is given by modulus B vector, and the opposite side no name. So a trigonometric ratio which connects adjacent side and hypotenuse side. Can you tell me which connects adjacent side and hypotenuse side? Here wanted adjacent side and known hypotenuse side. So wanted adjacent side and known hypotenuse side connecting trigonometric ratio, good, cos ratio, that is cos theta. So cos theta is equal to adjacent side by hypotenuse side. Why not sin theta? Sin theta is equal to opposite side by hypotenuse side. Okay, sin theta. But here opposite side no name. So that is why here adjacent side wanted, hypotenuse side known. So wanted, known, connecting ratio cos theta. Now in right angle triangle OLB, cos theta is equal to, in triangle OLB, cos theta is equal to adjacent side by hypotenuse side. Cos theta is equal to adjacent side by hypotenuse side. Okay. Now which is equal to, what is adjacent side? Yes, adjacent side equal to OL, and hypotenuse side is equal to modulus OB. That is just OB, which is a magnitude. Okay, listen, adjacent side is equal to OL divided by hypotenuse side is equal to, where hypotenuse side is equal to modulus B vector. One can write modulus B vector. Otherwise, modulus OB vector. Modulus OB vector is equal to modulus B vector. Okay, that is modulus B vector. Hypotenuse side equal to OB, where OB is equal to modulus B vector. Modulus OB vector equal to modulus B vector. Okay. Now cross multiply. Yes, we want to find we want to make OL equal to something. Okay, cross multiply. That means modulus B vector comes left side, becomes modulus B vector into cos theta, and already numerator is OL. What is OL? OL equal to modulus B vector into cos theta. Okay. Therefore, OL is equal to modulus B vector into cos theta. Okay, OL is ready. Now by the definition of dot product, again now we want to come the introduction, definition of dot product. Definition of dot product is given by A vector dot B vector equal to, now yourself. Okay, what is the definition of dot product? Good. Say first one A vector, therefore modulus A vector int second B vector. So int modulus B vector int cos theta, which is definition of dot product. Definition of dot product is given by A vector dot B vector is equal to first A vector, so first modulus A vector, second B vector, so second modulus B vector, int cos is angle of theta, where theta is the angle between A vector and B vector. Okay. Now say, what is modulus B vector into cos theta? Anyone? What is modulus B vector into cos theta? Good. Modulus B vector into cos theta equal to OL. So, which is equal to modulus A vector into OL. That's all. So, this underline is equal to OL, where OL equal to modulus B vector into cos theta from the before step. Now, what is LHS? Right as it is A vector dot B vector. Now, we want to find a OL is equal to, that is important, OL is equal to. For my convenience, reverse it. By reversing, we can write modulus A vector into OL is equal to A vector dot B vector. Okay? Now, make OL equal to something. Yes, this modulus A vector goes to right, becomes divided. So, your answer is OL is equal to A vector dot B vector divided by modulus A vector. Okay. OL equal to A vector dot B vector divided by modulus A vector. What is OL? Yes, very good. Where OL is equal to projection of B vector on A vector. Come to the diagram. In the diagram also, what is OL? OL is the projection of B vector on A vector. So, instead of OL, write the theory portion, projection of B vector on A vector. So, that is, therefore, projection of B vector on A vector, okay, which is equal to, see, OL equal to projection of B vector on A vector, which is equal to, write this RHS as it is, that is A vector dot B vector divided by modulus A vector. Okay. Now, which is an important formula. Projection of B vector on A vector is equal to A vector dot B vector divided by modulus A vector. Okay, modulus A vector is ready. Now, listen the technique. I have the technique. Here, on A vector. So, this the keyword which represents, see, the keyword which represents on A vector should lies in denominator. So, this on A vector comes in denominator. So, that is a technique. And this formula is not fixed one. According to the vectors interchange, we can change the formula. Here, projection of B vector on A vector, here on A vector comes in denominator and A vector B vector is numerator. A vector dot B vector in numerator, but whether modulus A vector denominator or modulus B vector is denominator. So, that is a problem. So, for that, the technique is on keyword comes in denominator, that is on A vector comes in denominator modulus A vector, that's all. Okay, similarly you can tell me projection of A vector into B vector interchange. Okay, projection of A vector on B vector equal to numerator fixed A vector dot B vector divided by here on B vector means denominator modulus B vector, that's all. Okay, similarly projection of listen, that is projection of A vector on B vector is equal to, okay sir, the projection of B vector, yes, the projection of A vector on B vector, which is equal to numerator as is well, A vector dot B vector divided by, now denominator only problem. So the what is the denominator? Whether denominator is modulus A vector or modulus B vector? Good. Denominator is modulus B vector. That's all. Again, first one. Projection of B vector on A vector is equal to, write the numerator fixed A vector dot B vector. But the denominator is on keyword comes in denominator modulus A vector. Similar idea. Projection of A vector on B vector is equal to A vector dot B vector divided by modulus B vector. So, which is second one. Okay, similarly, suppose I will change the keyword. Listen. Projection of AB vector. Projection of AB vector on CD vector, which is equal to, anyone? Very, very good, very good. Projection of AB vector on CD vector, which is equal to, the numerator is a dot product of these two. Numerator is a dot product of these two. That is, what is a dot product? AB vector dot CD vector divided by, what is the denominator? Very good. That is, on keyword comes in denominator, that is modulus CD vector. That's all. So the second topic is geometrical meaning of scalar product is nothing but projection of one vector on another vector. Okay, that is in this diagram projection of b vector on a vector is equal to a vector dot b vector divided by on keyword comes in denominator, therefore divided by modulus a vector. Suppose one can derive like this also. Suppose listen, for second formula, this a and b can be interchanged. Okay, a and b can be interchanged, which means let O be the origin and a, let OA vector is equal to a vector. Next, which is b, let OB vector is equal to b vector. Okay, now draw AL perpendicular to OB. This same bookwork we can derive in one more way also. Okay, both are correct. That is, the first diagram gives the first formula and the second diagram gives this second formula. That's all. Okay. Now, let theta be the angle between a vector and the b vector. And the similar way, here in this diagram, projection of a vector, listen carefully, projection of a vector on b vector. Projection of a vector on b vector is equal to a vector dot b vector divided by modulus b vector. Okay. Projection of b vector on a vector is equal to a vector dot b vector divided by modulus a vector. That's all. So this on a vector means denominator modulus a vector. Here on b vector means denominator modulus b vector. So this diagram only, suppose which is 3 more question. In 3 more question, derive geometrical meaning of scalar product. Derive geometrical meaning of scalar product means say diagram and this derivation fully, and this last two no need because it is formulas, that is new formulas, which is a basic. Using this basic we are writing 2 more formulas. That's children listen. Now third one. Third one is dot product is commutative. Listen carefully. Dot product is commutative. Dot product is commutative. That is, scalar product is commutative. Both are correct. Okay. Dot product is commutative. That is, scalar product is commutative. Okay. What is meant to be commutative? Anyone? Very good. 2 into 3 equal to 3 into 2 because 2 3s are 6 and 3 2s are 6. So dot product is commutative. That is, multiplication is product is commutative in real numbers. Multiplication is commutative in real numbers. Similar way, in vector algebra, dot product is commutative. Okay. So for this, first I need a definition of dot product. Very important. Every time we want to go to the definition of dot product. Listen, definition of dot product is given by a vector dot b vector equal to. Okay, start yourself. Very good. A vector dot b vector is equal to first one a vector. So modulus a vector into second one b vector. So into modulus b vector into cos theta, where theta is the angle between a vector and b vector. Again, from the definition of dot product, a vector dot b vector is equal to modulus a vector into modulus b vector into cos theta. Okay. Now can tell me what is b vector dot a vector? Anyone? B vector dot a vector? Very good. Very good. Again, by the definition of dot product, here first b vector, therefore first modulus b vector into. Okay. Second a vector, therefore into modulus a vector into cos theta. Okay. Suppose, can tell me what is b vector dot c vector? Anyone? B vector dot c vector? Very good. Here first b vector, so modulus b vector. Second c vector, so into modulus c vector into cos theta. Okay. Into cos theta. Similar idea. Suppose for example, pq vector dot rs vector. Okay, start. Very good. By the definition of dot product, first one pq vector. So modulus pq vector into second rs vector. So into rs vector into cos theta, where theta is the angle between pq vector and rs vector. That's all. So first definition of dot product is very important, and according to the situation going to change. A dot B equal to B dot A equal to B dot C equal to PQ vector dot RS vector equal to like that. Okay. Now the first line enough. Okay. Definition of dot product A vector dot B vector is equal to modulus A vector into modulus B vector into cos theta. Okay. Now the topic is commutative. Commutative means 2 into 3 equal to 3 into 2. Likewise. Here A vector dot B, we have taken A vector dot B vector. Now we want to prove, very good, we want to prove B vector dot A vector. That is A dot B equal to B dot A. That is commutative. Okay. Now listen. Now which is equal to modulus A vector is a scalar. Modulus B vector is a scalar. So these two scalars we can interchange. The value will not change. So for my convenience, this modulus B vector comes first. So modulus B vector. Say this first modulus A vector goes to second place. So into modulus A vector. Value will not change. Into cos theta. Okay. Modulus B vector and modulus A vector can be interchanged. For example, 2 into 3 equal to 3 into 2. Likewise. 3 4s are 12, 4 3s are 12. Likewise. Okay. Now which is equal to, listen, definition of dot product A vector dot B vector is equal to modulus A vector into modulus B vector into cos theta. Its converse also true. Converse means here first modulus A vector, so that is why first A vector. Second modulus B vector, that is why second B vector. Now can you tell me, now first modulus B vector, that is why what is first? What is first? Very good. B vector. Okay. First modulus B vector, therefore first B vector. Second modulus A vector, therefore second, yes, A vector. Yes. Initially we taken A vector dot B vector. Finally we proved B vector dot A vector. Write this left hand side, A vector dot B vector. So listen, A vector dot B vector is equal to B vector dot A vector. A dot B equal to B dot A. So dot product is commutative. So the third topic, dot product is commutative. That's all. Okay, third topic completed. Now come to, yes, fourth topic. See, to learn fourth topic, consider the diagram. Listen carefully. Let it be the origin O, and which is OA vector, and it is OB vector. Let OA vector is equal to A vector. Let OA vector equal to A vector. Now, let OB vector is equal to B vector. Okay. Now, what can you say about angle between A vector and B vector? Anyone? Very good. 90 degree. 90 degree, which is 90 degree or 5 by 2. Here, A vector and B vector are perpendicular. Okay. Now, come to the definition. By the definition of dot product. Now I want to move definition of dot product. Listen carefully. A vector dot B vector is equal to. Okay, what is definition of dot product? Yes, first A vector, so first modulus A vector. First A vector, first modulus A vector. Second B vector, therefore second modulus B vector. Into cos theta. Okay, into cos theta. Whether theta or any different angle? Very good, 90 degree, because here before definition theta is the angle between A vector and B vector. But now angle between A vector and B vector is 90 degree. Therefore cos is angle of 90 degree. That is very important. Okay. Here angle between A vector and B vector is 90 degree. Therefore cos is angle of 90 degree. Now can you tell me what is cos 90? Cos 90? Very good. 0. Because cos 0 1. Okay. Cos 0 1. Cos 90. 0. Sorry. Cos 0 1. Cos 90. 0. So cos 90 tends to 0. So 0 into anything equal to 0. So that is why A vector dot B vector is equal to 0. Listen carefully. If the two vectors are perpendicular, then its dot product is equal to 0. If the two vectors are perpendicular, then its dot product equal to 0. Conversely, if the dot product of two vectors is equal to 0, then the two vectors are perpendicular. So now I want to write conclusion. Listen, if that is A vector dot B vector is equal to 0, A vector dot B vector is equal to 0, if and only if. This symbol denotes if and only if. A vector dot B vector is equal to 0, if and only if A vector is perpendicular to B vector. That's all. and its converse also true. That is, if and only if means taking LHS true, that means RHS also true. If RHS is true, assume that RHS is true, therefore LHS is true. That's all. So if A vector dot B vector is equal to 0, therefore these two vectors, A vector and B vector, are perpendicular. Conversely, if A vector is perpendicular to B vector, therefore its dot product A vector dot B vector equal to 0. So A dot B equal to 0, then A vector and B vector are perpendicular. Okay, which is concept 4. Now listen, fifth topic. Okay, fifth topic is, say, suppose for example, A vector dot A vector. A vector dot A vector. Again, see, every time we want to use definition of dot product. Listen, definition of dot product is given by modulus A vector into modulus B vector into cos theta. Okay, now A vector dot A vector. Here, dot product of itself vectors. Itself. Sir, okay. Can you tell me what is the definition of dot product? Very good. First A vector, therefore modulus A vector. Second also A vector, therefore what is second? Very good. Modulus A vector. Modulus A vector into cos theta. What is theta? What is theta? Very good, 0. Because angle between A vector and A vector is 0. Angle between A vector and A vector. Listen, for example, suppose A vector, angle between A vector and A vector is 0. So that is theta is equal to 0 degree. Therefore, here we want to write cos 0. Okay, cos 0. Again, fifth topic, dot product of itself vectors is equal to, definition of dot product is given by modulus A vector into modulus A vector into cos theta, where theta is the angle between A vector and A vector. So angle between A vector and A vector is equal to 0 degree, therefore cos 0. Can you tell me what is cos 0? Very, very good. Cos 0, 1. Cos 0, 1. Now, yourself. So 1 into modulus A vector into modulus A vector. That is modulus A vector. See, modulus A vector into modulus A vector is equal to modulus A vector square. So which is equal to modulus A vector square. Okay. Now the left hand side is, see, which is modulus A vector square. Okay. Which is equal to modulus A vector square can be rewritten as A vector the whole square. And also we know that modulus A vector is equal to A. Magnitude of A vector equal to A. Magnitude of B vector is equal to B. Likewise, magnitude of C vector is equal to C. So therefore, modulus A vector, listen, forgetting square, modulus A vector is equal to A. Because of square, so A square. Now all these three are equal. That is, A vector dot A vector is equal to modulus A vector square is equal to A vector the whole square is equal to just A square. So now write 1, 2, 3, 4. All these 4 are equal. Okay. Now write its left hand side is given by A vector dot A vector. Now the conclusion is A vector dot A vector is equal to. Can you tell me what is A vector dot A vector? Yes. A vector dot A vector is equal to modulus A vector square is equal to, good, A vector the whole square is equal to A square. Okay. This result is very important for example and exercise. To solve examples and exercise, this formula is very important. Dot product of itself vectors is equal to A vector dot A vector is equal to modulus A vector square is equal to A vector the whole square equal to A square. Okay. Now fifth topic is completed. Now topic 6. Okay. Topic 6 1. Angle between A vector and B vector. Angle. Angle between A vector and B vector. Okay. Angle between A vector and B vector. I want to find the angle between A vector and B vector. Let theta be the angle between A vector and B vector. Listen, for my convenience, small diagram. Suppose origin O and let it be it is A vector and which is B vector. Let theta be the angle between A vector and B vector. Now, let theta be the angle between A vector and B vector. Now, can you tell me what is the definition of dot product? Very good. Definition of dot product is given by, see listen again. Definition of dot product is given by A vector dot B vector. A vector dot B vector is equal to, yes, first A vector, so modulus A vector, into second B vector, so into modulus B vector, into cos theta. Okay. Now for my convenience, reverse it. By reversing, we get modulus A vector into modulus B vector into cos theta, which is equal to, yes, which is equal to A vector dot B vector. See, the topic is angle between A vector and B vector, angle between two vectors, that is angle between A vector and B vector. Now, by the definition of dot product, A vector dot B vector is equal to modulus A vector into modulus B vector into cos theta. For my convenience, reverse it. Now, I want to make cos theta equal to something. Can you tell me cos theta equal to? Good. Modulus A vector goes to right, becomes divide. Modulus B vector goes to right, becomes divide. Can you tell me what is cos theta? Good. Cos theta is equal to, okay? Cos theta is equal to A vector dot B vector divided by modulus A vector into modulus B vector. That's all. So, angle between two vectors, angle between A vector and B vector. Angle between A vector and B vector is given by the formula cos theta is equal to A vector dot B vector divided by modulus A vector into modulus B vector. Listen, here three, say from 2 onwards, first one is definition and say second one is a projection of B vector on A vector. So second, third, fourth, fifth, sixth, all are we are deriving from definition, every time definition of dot product. So all the formulas we are deriving from definition of dot product. Okay, now can you tell me, suppose here angle between A vector and B vector is given by cos theta is equal to A vector dot B vector divided by modulus A vector into modulus B vector. And this formula is not fixed. According to the vectors, it is going to change. Okay, listen. Now can you tell me, and suppose angle between B vector and C vector. Can you tell me what is angle between B vector and C vector? Anyone? Very good. So angle between B vector and C vector is given by cos theta equal to B vector dot C vector divided by modulus B vector into modulus C vector. Sir, okay. Suppose angle between C vector and A vector. Angle between C vector and A vector. Very good. Cos theta is equal to C vector dot A vector divided by modulus C vector into modulus A vector. Like that, going to change. Suppose angle between PQ vector and RS vector. Angle between PQ vector and RS vector is given by the formula. Yes, very good. That is cos theta is equal to PQ vector dot RS vector divided by modulus PQ vector into modulus RS vector. So this formula going to change according to the question. Children listen. Now property 7. Okay, property 7. That is distributive laws. Say for example, A vector dot B vector plus C vector is equal to, okay, A vector dot B vector plus C vector is equal to. Now it is very simple. Distributive law as in 10th standard. Here A vector and the dot product going to multiply inside the bracket. That's all. Okay. Now listen. A vector dot B vector plus A vector dot C vector. Okay. That is, here dot is distributive over addition. The dot product is distributive over addition. Okay, now start. Again, it is very simple. A vector and the dot product going to multiply inside the bracket. Your answer is A vector dot B vector plus A vector dot C vector. Okay, which is equal to A vector dot C vector plus, next step, very good, A vector dot C vector. A vector dot C vector. Suppose A vector dot B vector minus C vector. Can you tell me what is this answer? Here what is the difference? Very good. Here plus, here minus. But the same working rule. Here also A vector and the dot product going to multiply inside the bracket. We get A vector dot B vector. Yes, sorry, here B vector. Okay, listen again. A vector dot B vector first term, then A vector dot C vector is second term. Here also A vector dot B vector first term. Okay, minus, because here middle minus, okay, plus into minus, minus, minus A vector dot C vector. A vector dot C vector. Okay. Now listen, eighth one. Eighth one is, for example, A vector plus B vector, the whole square is equal to A vector plus B vector, the whole square equal to. Okay, and this formula is comparing with the algebra formula. Listen, in algebra, can you tell me what is A plus B whole square? Anyone? A plus B whole square equal to? Very good. A plus B the whole square equal to A square plus B square plus 2AB. Okay, similarly, can you tell me what is A minus B whole square? A minus B whole square equal to A minus B whole square equal to A square plus B square minus 2AB. Okay, what is A plus B into A minus B? A plus B into A minus B equal to? Very good. A square minus B square. So, these three are algebraic formulas. A plus B whole square equal to A square plus B square plus 2AB. A minus B whole square equal to A square plus B square minus 2AB. A plus B into A minus B equal to A square minus B square. And its reverse also true. Converse also true. Sir, okay. But in vector algebra, already we learned that is itself multiplication. A vector dot A vector equal to. Can you tell me itself multiplication of that is dot product of itself vectors? Very good. A vector dot A vector is equal to modulus A vector square, which is equal to, yes, modulus A vector the whole square, which is equal to A square. So one can use anyone. So one can use first or second or third. Okay. Now usually we are using second one. So A vector dot A vector equal to modulus A vector square. Okay. And similarly, B vector dot B vector equal to modulus B vector square. C vector dot C vector equal to modulus C vector square. Likewise, here A vector plus B vector the whole square equal to, in vector algebra, in real numbers, A plus B whole square equal to A square. First term A, so A square. Second term B, B square. But in vector algebra, first term A vector, so use modulus A vector square. That is A vector the whole square. A vector the whole square equal to modulus A vector square. Okay. So first term A vector, so A vector the whole square equal to modulus A vector square. So modulus A vector square plus. Okay. Second B vector. What is B vector the whole square? B vector the whole square equal to B vector, that is B vector the whole square equal to modulus B vector square. Okay. So plus modulus B vector square plus 2 into, now here only problem. In algebra, A square plus B square. In algebra, A square plus B square. But in vector algebra, write modulus A vector square, modulus B vector square. Modulus A vector square plus modulus B vector square. Here simply we are in algebra, we are writing simply 2AB. But in vector algebra, that is simply writing A vector B vector is meaningless. So which is meaningless? If you write simply A vector B vector is meaningless. When it becomes meaningful means between A vector and B, between A vector and B vector, any one operation must need. Suppose middle plus, okay, yes, correct. Middle minus, okay, correct. And middle sometimes product also correct. And middle either dot product or cross product. That which is in next exercise. Suppose A vector plus B vector, A vector minus B vector, A vector dot B vector, A vector cross B vector. So these are meaningful. And if you write similarly, A vector B vector means is meaningless. So between two vectors we need a relation, any one relation, whether addition or subtraction or dot product or cross product. Okay, now the topic is that is a dot product. So that is why here instead of 2AB we want to write 2 into A vector dot B vector. That is important. So plus 2 into A vector dot B vector. Okay, so don't write simply 2A vector B vector is meaningless. 2A vector B vector is meaningless. So that is important. This step is very important. Okay, again listen, it is comes from algebraic formula. A vector plus B vector the whole square is equal to modulus, here first one modulus A vector. So modulus A vector square, second B vector. So modulus B vector square plus 2AB. But in vector algebra, between two vectors we need a relation which is dot product, A vector dot B vector. Okay, similarly can you tell me what is A vector minus B vector the whole square? Yourself. What is the difference? Very good. Here plus, here minus. That means plus 2ab, minus means minus 2ab, remaining all. Okay, same. Now start. Modulus a vector square plus modulus b vector square minus 2 a vector dot b vector. That is important. Here dot is important. In algebra, just a 2ab, 2ab. But in vector algebra, 2 a vector dot b vector. That is important. Okay, similar idea. A vector minus b vector into a vector plus b vector. One can write. That is, it is of the form a minus b into a plus b or a plus b into a minus b. Both are correct. Why not? One can learn a plus b into a minus b. Okay. A plus b into a minus b. A plus b into a minus b equal to a plus b into a minus b equal to a square minus b square. But in vector algebra, let us use a square equal to modulus a vector square. So, which is equal to modulus a vector square minus modulus b vector square. Okay. So these three are algebraic formulas. So these are all rough work. No need. Which is rough work. Okay. This is 8th one. A vector plus b vector the whole square equal to modulus a vector square plus modulus b vector square plus 2a vector dot b vector. And here plus minus. So plus minus. That's all. A plus b into a minus b equal to a square minus b square. But in vector algebra, a vector plus b vector dot, middle is dot, very important. Here middle dot product. Okay, dot. Middle dot. Dot a vector minus b vector. Okay. A vector plus b vector dot a vector minus b vector, which is equal to a vector square modulus a vector square minus modulus b vector square. Already I told you, between two vectors we need a relation. So that is dot product. Simply write a plus b, a vector plus b vector into a vector minus b vector is meaningless. This middle dot only gives meaningful. That's all. So now can you tell me, suppose I will change the numbers. For example, b vector plus c vector the whole square. Anyone? B vector plus c vector the whole square. Very good. First one b vector, so modulus b vector square. Okay. Next plus. Second is c vector, so modulus c vector square. Plus 2 b vector dot c vector. That is important. Here dot is important. Okay. Suppose here minus means here minus. That's all. Suppose for example, b vector plus c vector dot b vector minus c vector, which is equal to, very good, modulus b vector square minus modulus c vector square. Like that we can derive the formulas. Children listen. Now property 9th one. Listen. Suppose 9th one. Okay. Which is very important. First to learn property 9, we need this diagram. Listen carefully. Z axis, okay, y axis and x axis. Okay, listen. X axis, y axis, z axis. Here x axis, y axis, z axis are perpendicular to each other. Okay, let O be the origin. Which is in 3-dimensional figure. Already we completed in exercise 8.2. Here x axis, y axis, z axis, which is in 3 dimensions. Okay. See, along x axis, let the unit vector is I cap. Along x axis, let the unit vector is I cap. Along y axis, the unit vector is, very good, because already we learned along y axis, the unit vector is j cap. Okay. Along z axis, the unit vector is k cap. Here, I cap, j cap, k cap are the unit vectors perpendicular to each other. That is, I cap, j cap, k cap are mutually perpendicular to each other. Okay, mutually perpendicular. This concept. Which means what? Angle between I cap and j cap is equal to, very good, 90 degree. Angle between j cap and k cap equal to 90 degree. Angle between k cap and I cap is equal to 90 degree. So that is the meaning. Okay, now every time we want to go through the definition. Okay, listen, by the definition of dot product is given by a vector dot b vector equal to, can you tell me a vector dot b vector equal to? Very good. A vector dot b vector equal to modulus a vector int modulus b vector int cos theta. Okay, which is a definition. Okay, now for my convenience, I want to take I cap dot I cap. Listen carefully. I cap dot I cap, okay, which is equal to, I cap dot I cap, which is equal to, okay, I cap dot I cap is equal to, okay, go to by the definition of dot product. Okay, start your answer. Anyone? Very good. That is first I cap, so modulus I cap, which is equal, that is int. Second I cap, so modulus I cap. Okay, here first A vector, so modulus A vector. Second B vector, so second modulus B vector. Likewise, so here first I cap, so modulus I cap. Second I cap, so modulus I cap. Second also modulus I cap. Okay, modulus I cap into modulus I cap into cos theta. But here angle between A vector and B vector is theta, that is why cos theta. But now angle between I vector and I vector. Angle between I vector and I vector. What is angle between I vector and I vector? Very good. That is 0 degree. So cos 0. Angle between I vector and I vector is 0 degree. Okay. Now simplification yourself. Start. Very good. Cos 0 1. Very good. Cos 0 1. Next step. Yes. Here I cap, j cap, k cap are perpendicular unit vectors. Okay, unit vectors means what? Good, its magnitude is equal to 1. So modulus I cap tends to 1. Modulus I cap tends to 1. Cos 0, 1. So 1 into 1 into 1? Yes, 1. Which is I cap dot I cap. I cap dot I cap is equal to 1. Okay. I cap dot I cap is equal to 1. What is meaning this? Yes, that is dot product of itself unit vectors is equal to 1. Dot product of itself unit vectors is equal to 1. Okay, similarly, can you tell me what is j cap dot j cap is equal to 1? K cap dot k cap is equal to 1. Okay, now listen the conclusion. Conclusion is I cap dot I cap is equal to 1. Similarly, j cap dot j cap is equal to 1 unit. That is k cap dot k cap is equal to 1. Yes, which is a property. I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap is equal to 1. That's all. Okay, now I want to consider I cap dot j cap. Okay, let us consider I cap dot j cap. First work, dot product of itself unit vectors is equal to 1. Now, dot product of different unit vectors, that is I cap dot j cap. Okay, what is answer? Yes, very good. By the definition of dot product, listen. A vector dot b vector is equal to modulus a vector into modulus b vector into cos theta. Every time we want to use definition of dot product. That is very important. Okay, which is equal to first one modulus I cap. So modulus I cap into second. Very good. Modulus j cap. Okay, modulus j cap into cos theta. Okay, I cap dot j cap is equal to modulus I cap into modulus j cap into cos theta. What is theta? Anyone? Very good, 90 degree. Why? Because? Good. Angle between I cap and j cap. Listen, angle between I cap and j cap is equal to 90 degree. Okay, so that is why cos 90. Cos 90. Now, yourself, simplification yourself. Very good. Modulus I cap tends to 1. Modulus j cap tends to 1. Cos 90, 0. Very good. Cos 90 is 0. Now, 0 into 1 into 1. That is 0 into anything? 0. Which means I cap dot j cap is equal to 0. I cap dot j cap is equal to 0. Okay. Similarly, listen from the diagram. I cap dot j cap equal to 0. Similarly, j cap dot k cap equal to 0. K cap dot I cap is equal to 0. Cyclic order. Okay, listen again. I dot j equal to 0. J dot k equal to 0. K dot I equal to 0. And already we know that dot is commutative. Dot is commutative. I cap dot j cap equal to 0 and j cap dot I cap is equal to 0. Dot is commutative because A dot B equal to B dot A in vector algebra. Okay. Now, therefore, I cap dot j cap is equal to 0. Okay. Next, suppose I cap dot j cap is equal to 0. Next, j cap dot k cap equal to 0. J cap dot k cap equal to 0. Next, k cap dot I cap. K cap dot I cap is equal to 0. That's all. And its dot product also equal. That is commutative. Dot product is commutative. So dot product is commutative equal to 0. Dot product is commutative equal to 0. Dot product is commutative. That is I cap dot k cap also equal to 0. Okay. It is next property. Okay. Next result. Now listen again. I cap dot I cap equal to j cap dot j cap equal to k cap dot k cap equal to 1. But I cap dot j cap, that is different vectors, means answer is 0. Now these results we can put into the table. Listen carefully. Here dot product I cap, j cap, k cap, I cap, j cap, k cap. Okay, complete the table. Yes, let us complete the table. Draw the horizontal lines. Draw the horizontal lines. Then draw the vertical lines. Okay, fill the table. Okay, start here. Dot. The product is dot product. Okay, now here I cap dot I cap equal to, very good, 1. Similarly, suppose here j cap dot j cap is equal to 1. Okay, come to here. K cap dot k cap equal to 1. Good. Next one, come to here. I cap dot j cap. Here I cap dot I cap itself multiplication, that is itself. So 1 answer. J cap dot j cap itself. So answer 1. K cap dot k cap. So 1 itself. Now here I cap dot j cap is, see the diagonals comes the first box. Okay. Now I cap dot j cap equal to 0. That is different means answer 0. Okay. I cap dot j cap 0. I cap dot k cap 0. Okay. Hereafter yourself. Start here. J cap dot I cap, good, 0. Next. Here j cap dot k cap 0. K cap dot I cap 0. K cap dot j cap 0. Yes, the table is filled. Okay. Now, which is 9th one is completed. Now listen. Now the 10th concept is very important. The concept is, suppose, listen carefully, let A vector is equal to A1i plus B1j plus C1k. Let A vector equal to A1i cap plus B1j cap plus C1k cap. Okay. Suppose B vector is equal to, okay, let B vector is equal to, let B vector is equal to A to I plus B to j plus C to k. For example, we are taking for example. Okay. Now I want to find a dot product, that is A vector dot B vector is equal to A vector dot B vector equal to. Okay, sort your answer. A vector dot B vector is equal to, where A vector A1i cap plus B1j cap plus C1k cap. Okay, dot, what is B vector? Yes, B vector is equal to A to I cap plus B to j cap plus C to k cap. Okay, now which is equal to, now listen, here dot is defined between two vectors. Okay, now I want to multiply. First of all, this first element going to multiply all the elements in the second bracket. Okay, start your answer, mind yourself. Say A1 I cap dot A to I cap. Here first is scalar into scalar. A1 into A2, A1 A2. But I cap dot I cap dot I cap is equal to 1 unit. So we are going to get answer. That is I cap dot I cap is equal to 1 unit. Therefore A1 A2 it will be the answer. Next, I cap dot j cap. Anyone? Yes, 0. No need to write. Next, I cap dot k cap. Yes, very good. 0. No need to write. Okay, similarly, This second time going to multiply all the elements in the second bracket. Okay, start your answer. J cap dot I cap 0, no need. J cap dot J cap 1, yes. But the coefficient is B1 into B2 into 1, therefore B1 B2. Next step. This J cap dot K cap, yes, very good, 0. No need to write. Okay, similarly, this C1 K cap going to multiply all the elements in the second bracket. That means K cap dot I cap 0. K cap dot J cap 0. K cap dot K cap 1. That means K cap dot K cap means K cap dot K cap 1. So the coefficient C1 into C2 will be the answer. Okay, what is the conclusion, please? Very good. See, if the dot product is defined between two vectors means it is enough to multiply itself multiplication. It is enough to multiply itself multiplication I to I, J to J, K to K. And it is enough to multiply only the coefficient. Listen, if the dot product is defined between the two vectors means itself multiplication, that is I to I, J to J and K to K. It is enough to multiply only the coefficient. Okay, and the different vectors dot product equal to 0 because this second box. Okay, now your answer is I cap dot I cap 1. Therefore, it is enough to multiply only the coefficient. So if the dot product is defined between the two vectors means it is enough to multiply itself multiplication. It is enough to multiply only the coefficient. I to I possible, A1 into A2 will be the answer. A1, A2. That's all. Please here obtain yourself. Very good. J to J present, J to J possible, B1 into B2. B1 into B2 plus K to K possible. Okay. That is C1 into C2. C1 into C2 whose left hand side is A vector dot B vector. So this 10th property is given by here. Initially we are using definition of dot product. Definition of dot product is given by A vector dot B vector is equal to modulus A vector into modulus B vector into cos theta. But now the same A vector dot B vector is given by the value. So that is why here by the value of dot product. Yes, by the value of dot product. Value of dot product. Value of dot product. Okay, it is value of dot product. So dot product is expressed in two ways, that is value of dot product and definition of dot product. Okay, it is value of dot product and it is definition of dot product. Now for our convenience, let us consider 11th one. Dot product can be expressed in two ways. Dot product can be expressed in two ways. That is, first one is by the definition of dot product. By the definition of dot product. Okay, by the definition of dot product. By the definition of dot product or by the definition of scalar product. By the definition of dot product is given by A vector dot B vector is equal to modulus A vector into modulus B vector into, very good, into cos theta. Okay. Now the second one is by the value of dot product. By the value of dot product. Okay, by the value of dot product. Dot product can be expressed in two ways. First one, by the definition of dot product, A vector dot B vector equal to modulus A vector into modulus B vector into cos theta. Okay. Second one is by the value of dot product. Say for example, A vector dot B vector is equal to, okay, suppose A vector is equal to I cap minus J cap plus 2K cap. Okay. Dot, suppose A vector equal to first. Dot, say, let it be, suppose B vector is equal to, suppose B vector is equal to 2I cap minus 4J cap plus 7K cap. So it is a situation. Okay. Listen, A vector dot B vector is equal to A vector equal to first one dot here middle dot, so that is why middle dot, and B vector equal to second bracket, for example. Okay, now from 10th property, if the dot product is defined between the two vectors, means it is enough to multiply itself multiplication, that is I to I, j to j, k to k. It is enough to multiply only the coefficient. Okay. Now listen, can you tell me direct answer start? Yes. I to I. What is your answer? Yes. Here coefficient 1, here coefficient 2. So 1 to E is 2. That's all. Here coefficient 1, coefficient 2. I to I percent. So 1 to E is 2. Next about j to j. Start yourself. Very good. Here minus 1 coefficient. Here minus 4. Minus into minus plus. 1 4 is 4. So plus 4. Similarly, k to k. Okay. Here plus 2. Here plus 7. 2 7s are 14. So plus 14. Okay. What is your answer, please? Yes. 6 plus 14 is equal to 20. So which is value of dot product. A vector dot B vector. A vector dot B vector equal to 20. That's all. Okay. Suppose 1, 2. So dot product can be expressed in two ways. That is, one is by the definition of dot product. Second one is by the value of dot product. Okay. If the dot product is defined between the two vectors, means it is enough to multiply itself multiplication. It is enough to multiply only the coefficient. I to I possible, 1 to is 2. J to j, 1 4 is 4. Minus into minus plus. K to k, 2 7s are 14. But what about I cap dot j cap? 0. Because this second property is 0. So different vectors product is 0. Really I cap going to multiply all the elements in the second bracket. But I cap dot j cap 0. I cap dot k cap 0. So it is possible only I cap dot I cap. Therefore it is enough to multiply only the coefficient. That's all. It is enough. Suppose, say for example, note is, suppose A vector dot B vector. Okay. A vector dot B vector equal to, suppose A vector is equal to I cap plus j cap. Dot B vector is equal to j cap minus k cap. So it is a situation. Listen again. Let A vector equal to I cap plus j cap. B vector is equal to j cap minus k cap. Now, if the dot product is defined between the two vectors, means what is the technique? Yes, itself multiplication. It is that is I to I, j to j, k to k. It is enough to multiply only the coefficient. And we are given one model. Okay, 1 2 is 2, minus into minus plus 1 4 is 4, and 2 7s are 14. That is I to I, j to j, k to k. Similar idea here. Okay, start yourself. Very good. I percent. I absent, no need to multiply. No need to multiply. I percent, I absent, no need to multiply. Okay, next step. Here I percent, I absent. We can't multiply. And if you multiply now, your answer is 0. Okay. That is I cap dot j cap 0. I cap dot k cap 0. So that is why no need. Okay, next step. J cap dot j cap possible or not? Yes, possible. J cap dot j cap is possible. J cap dot j cap is equal to 1. That is here coefficient 1, here coefficient 1, so 1 is the answer. Next, k absent, k present, no need to multiply. So for this it is one more question. Here I present, I absent, no need to multiply. J present, so possible to multiply. That is coefficient 1, coefficient 1, 1 into 1 is equal to 1. Here k absent, k present, no need to multiply. So your answer is A vector dot B vector is equal to 1. Okay. Suppose the next question is A vector dot B vector is equal to I vector plus J vector plus K vector. That is K cap. A vector dot B vector is equal to I cap plus J cap plus K cap dot, suppose for example, dot 2I cap plus J cap. So it is a situation. Now, yourself. Okay, start. Yes. I present. I to I possible. 1 to is 2. Okay, next. J present. What is your answer? Yes. J to J possible. 1 into 1, coefficient 1, coefficient 1 into 1, 1. Okay, next k percent, k offset, no need to multiply. So which is equal to 3 will be the answer, which is A vector dot B vector. A vector dot B vector is equal to 3. Okay.